We have been in this Grand Design Momentum 410TH that we helped design for almost 3 years now. I can't believe how much the time has flown. But you might remember that when we got this system way back then, we had a prototype power system from Volta Power Systems in this RV, and we made this video about it. That system was a beast, but for whatever reasons outside of my purview, that whole OEM relationship between Grand Design and Volta Power Systems never came to fruition. And while we were out traveling around with a power system that would never be, Grand Design came out with their ELP. This stands for their Extreme Lithium Package. So last winter, we took our RV up to Elkhart for a retrofit of that system as well as some others and made this video. But now that we've had this system, the ELP system, all year, it's time to kind of give you guys an overview. Couple of notes before we jump in. You're going to hear me use a lot of acronyms like ELP and VPS. VPS is just Volta Power Systems, and ELP is just a short way to say Extreme Lithium Package. Also, I'm going to talk a lot about various power situations and wattage and amperage, but I'm going to try to keep it really very simple. I'm only going to use watts, and we're going to use some basic addition and subtraction, so we're not going to go deep into the woods. That being said, the numbers that I'm going to use are like theoretical numbers. When I'm talking about I'm running 2 ACs and 1 AC or whatever, obviously a lot more is running. The wattages that I'm going to use as examples aren't exact. When I'm talking about creating energy from DC to AC or AC to DC, there is power loss in those conversions. I'm not going to go into the weeds and do all of that. I mean, if I tried to rack up every watt here and there, we'd be here all day. Also, in videos like this, we don't usually mention the price, simply because as soon as we put this video out, the prices are probably outdated. Additionally, on something like this, the ELP, it can only get it as a factory option. And you can find the price for that using the build-in price tool on Grand Design's website. But remember, that's MSRP, and if you're paying MSRP for your RV, don't. And before we jump into the ELP, I do want to quickly mention a little bit about the Volta Power System that isn't, because a lot of you still reach out and ask, hey, whatever happened to that Volta Power System? Can that be purchased separately even though Grand Design isn't partnered with them now? And the answer is no, because a lot has happened with Volta Power Systems in this past year. In fact, the Volta Power Systems is no more. This is all very new, and I'm no expert in this kind of thing, but it sounds to me like they didn't declare bankruptcy, but kind of went bankrupt. The assets were sold. I don't really understand, but it sounds like the current owners of Volta Power Systems might be SOL. If you know more about this situation than I do or how it worked out, do put your comment down below. I'm really curious to read about that. You know, it sounds like it's just kind of a bad situation all around. So with that dire news of Volta out of the way, let's jump into this ELP system. Now that we've had a chance to use it for a year, I feel confident telling you guys about it. Overall, really like the system. It's been working great. However, I did find one little snag in a particular scenario that I will cover later on in the video because I also found a fix for it. First, let's look at the physical installation of this thing, and honestly, this part is really genius. Normally, when you're building out an inverter system, you've got, like dual inverters, 2 or 3 or more, a couple of solar charge controllers, you've got batteries. This stuff all takes up a lot of space, and generally you're going to give up some basement space. So the way they did this is really cool, and that is on this tray that sits in the front bay. Our front bay is now divided into 2 sections, and that top section, it's just completely hidden up there out of the way. It is so cool. On that tray, you have both inverters, both solar charge controllers, the DC to DC, all wired in together with the breakers and everything all in one tray that folds up out of the way. Super cool. The batteries are right down below there in the left-hand side, also completely out of the way, leaving room for extra storage on the right or for a generator, which is what we have. So this entire dual inverter system sits in that front bay, and none of the basement area is affected. The physical install of this system is better than anything I've ever seen. I really like it. Now let's talk about the gear itself, which is all from TBB Power. The default battery bank is two 400 amp hour 12 volt batteries. That's 800 amp hours if you like that kind of nomenclature. You know, I prefer watts and kilowatt hours because that translates across all voltages. So you're looking at about 10 kilowatt hours of battery in this system. Now that space down there can fit 3 batteries, which is what we did. So we added on an extra battery. So we have about 15 kilowatt hours. Now, if you want to add that extra battery to upgrade from 10 kilowatt hours to 15, you can have that done. Just work through your dealer on that. If 15 kilowatt hours isn't enough for you, the system does support up to 8 batteries. That's over 40 kilowatt hours. That's a ton. But obviously that's not going to fit in that tiny space. You'd have to figure out where to put it. I don't think you could do that from the factory, but you could add them later. I'm not real sure. But again, talk to your dealer if you're interested. These batteries have all of the features that you would expect from a high-end system. The built-in BMS in each battery. Each battery has built-in heating, built-in Bluetooth, built-in CAN bus, which allows the batteries to talk to the overall ELP system, so you can see the status of all the batteries right here in the system. Additionally, each of these batteries are wired into the ELP tray, into that system individually. That means that it's not wired like as a single bank, and then that bank is wired in. Each battery is wired in separately. I really like this because it allows each BMS to kind of manage each individual battery. You don't have any kind of balancing issues. Additionally, if one battery fails, it doesn't affect the whole system, just that one battery. It has two 50 amp MPPT solar controllers fed by 4 330 watt bifacial solar panels, providing a total of 1,320 watts of solar. It has a 60 amp DC to DC charge controller so that you can actually charge from the truck. Now we haven't used this simply because it does require some extra wiring in the truck. It doesn't require a separate alternator, but does require the wiring. We haven't done that, and I'm going to get into that a little bit later when we talk about scenarios. The core of the system is two 3,000 watt inverters. These inverters are single line, so one inverter handles one side of the RV and one inverter handles the other. If you're not familiar with a 50 amp RV versus 30 amp, just a real quick refresher here. A 30 amp RV, it's got one leg and the entire RV is 30 amps. When you've got a 50 amp RV, what you really have are two separate 50 amp legs in a split phase kind of scenario. That's getting too technical, but you've got essentially 100 amps of power available in a 50 amp RV. Technically, you have 240 volts because they're out of phase. And I've never actually seen 240 volts used in an RV. Usually it's just one line and one line doing 120. But some RVs, theoretically, you could have a 240 volt application, like maybe an EV charger or a MIG welder. I don't know. You can use 240 if you need it, it's there. So you do have 3,000 watts available, straight inverting to each line. Everything in the RV is powered. This is set up just like I've done previous installs where I wire the inverter into the system so that everything is powered. There are no sub panels or anything like that. But if you're familiar with inverters, these inverters are no different than Victrons and everybody else's. Even though it's rated at 3,000 watts, that's a little bit misleading because it's really 3,000 volt amps. And what you're not getting there is the fact that you lose some energy during the conversion process from DC to AC. You're lucky to get probably 80%. So really a 3,000 watt inverter is going to give you about 2,400, 2,500 watts of real power to your system. But you still got plenty of energy on each line to run all 3 ACs. And that's like the holy grail of inverting systems, right? You want to be able to run all your stuff and you want to be able to run your ACs. So this system checks all of my primary goals with an inverter system. My number one goal is to power the whole RV, run everything, be able to power everything. I also want to be able to run as many things as I can simultaneously, run everything at once, run 3 ACs. I also want to be able to run them as long as I can. That's your kilowatt hours or your amp hours of your batteries. So this thing checks all the boxes. In reality, the way we camp, our primary goal is usually just to run 1 AC all night long with enough power left over in the morning to make coffee. This thing does that. You can monitor and control this system right through this little control panel right down here. You can also control it via an app on your phone over Bluetooth. Currently no Wi-Fi access to this right now, maybe in a future version, I hope, but you can control and see everything through the panel here or on your phone. And most importantly, it tells you based on your current load, how much time is remaining. That's the key. So let's walk through a few camping scenarios so you can kind of see how this system handles each of those scenarios. First of all, 50 amp power, not a whole lot to say there. It's not being used a lot because both inverters are pretty much just in pass-through mode and you're hooked up to shore power. One feature of this system being integrated so well is that it does act like a giant UPS. A UPS is an uninterruptible power supply. You might have seen these on computer systems. So if the power goes out in the house, the computer system doesn't have that power spike or fluctuation and it just keeps running till the power comes back on. Well, this system acts just like that. If power goes out at the pedestal, this system kicks right in seamlessly. Usually you can't even tell it happened. Now let's switch to the opposite. No power whatsoever, or you're boondocking or dry camping or whatever. This is the way we use the system most, and I'm calling this pure inverting. This is what we use when we stop overnight at Harvest Host and we want to run our AC at night, make coffee in the morning. I kind of touched on this already. But pure inverting, you've got 3,000 watts available on each line, and that's plenty to run all three ACs. With the 15 kilowatt hours, you could run all three ACs for about 3 hours maybe. Not really useful, but it can be done. Like I mentioned, our goal is usually to run one AC all night. But another thing of note in the pure inverting mode, the inverters are synced and they are putting out split phase. So you do still have 240 volts available, which isn't going to be used by most people. We won't use it, but it's there if you need it. So let's talk about a partial power situation. Maybe you are in an old RV park that only has 30 amp pedestals. Unlike 50 amp, like I mentioned, which is really 100 amp, your 30 amps is 30 amps, period, end of story. You have 3,600 watts available for everything. Now on that 3,600 watts or 3.6 kilowatts, you can probably get two ACs running if you have soft starts on them, but without that, you'll be lucky to get two ACs running, but you can definitely run one on 3,600 watts. Again, this is talking without the ELP. Now, with the ELP, that all changes. When the ELP detects your 30 amp by seeing that you've got single phase, it takes inverter 1 on line 1 and puts it into a hybrid mode. Hybrid mode means that it can just pass through power and then take the excess and charge, or it can pass through power, and if you need more power, do some inverting and boost it to run more on that line. Inverter 2 goes into an invert only mode. So inverter 1 in hybrid mode will take that 3,600 watts available from the pedestal and it will pass through anything to loads, and then anything left over from that 3,600 watts it can use to make DC power and supplement the inverting that inverter 2 is doing. So let's look at how this ELP system on 30 amp would handle running 3 ACs. So let's say you've got 2 ACs using 2,500 watts on line 1. In that scenario, it's going to pass through 2,500 watts to run those ACs on line 1, and you're going to have 1,100 watts left over for DC charging. Running one AC on line 2 using about 1,300 watts, it's doing full inversion to run that 1,300 watts, but it's supplemented by the 1,100 watts from the charging from inverter 1. I'm sorry, this is a little complicated. It's just the way it is, but that gives you a net negative battery usage. It gives you, you're having to draw some energy from the batteries of about 200 watts. Now again, everything is, variable and you're going to have more things running. But the whole point of this is, whereas you can't normally run 2 ACs sometimes, definitely never 3 ACs on 30 amp, this system lets you do that. So you can be plugged on 30 amp and pretty much use your RV like you're on 50 amp with energy coming and going from the batteries as needed. Now let's talk about if you do have the generator option like we have. Since the generator puts out single phase, it's going to look to the ELP system just like 30 amp would. The difference here is we have a 6,000 watt generator versus 3,600 watts from the pedestal. So with that 6,000 watts, theoretically that's enough power. You should be able to run all 3 ACs maybe all day, and enough energy left over to keep the batteries topped off to go into full inverting mode at night. We had that plan and we tried this in Key West, and the result was this. Well, our plan A was to not need the ACs because it was in April in Key West and we hoped it would be cooler, but we ran into a hot spell and it is what it is. And we ended up with a situation where we hoped to run all 3 ACs during the day on the generator and then have that surplus of energy, keep the batteries topped off or charge the batteries all day, and then go into inverting mode at night, drain the batteries down, kick the generator back on, rinse and repeat. But we were unable to. No matter what I tried, I kept ending up with a net negative on our batteries, meaning that we could run all 3 ACs for most of the day, maybe even all day, but we wouldn't end up with charged batteries. And it was so stinking hot. We were so tired and exhausted. I didn't want to try to figure it out right then. So we bailed and went to our friend's mooch docking location with 50 amps and glorious AC. And I waited until I got back here to the cabin to troubleshoot it. Hey, you've made it this far in the video and you might notice this video has no sponsor. We're sponsoring this one. So if you could do me a favor, and if you could click that thumbs up button, click the subscribe button if you haven't already, that would help us out. That would be really great. And if you want to support the channel, holiday season's coming up, we have a store that has everything we've ever tried and experimented with and and recommend to you guys. It's across all of our partners and Amazon, so you can find it all in one place. I'll link that down below if you want to use that during your Christmas shopping season to shop for your RVer. Please do. We'd really appreciate it. So we got back here to the cabin and I was finally able to do some troubleshooting. Now, I'm not going to bore you with all of the logic and reasoning and figuring out, how I figured out these things. I'm going to jump straight to the issues that I found and their solutions so we don't take all day. Also, per usual, and things like this, but particularly with things with electrical, I am not recommending you do these fixes if you have this system. I am showing you how I did it. And if you want to take that on, have at it. But if you don't, if you're not familiar with electrical and electricity, have a professional like an NRVTA, certified professional RV tech come help you. Because if you're not familiar with it, you could get yourself in trouble. So issue number 1 was actually pretty easy because I had already had this issue before. And that's in how the generator is wired into the system. The generator, both our last generator, our Onan, and this NPS, split out their power when it leaves the generator into 2 breakers. So even though I've got 6,000 watts total available, it's been split up so I can really only get 3,000 watts on either side. Now that's fine if you've just got a generator with no ELP or inverter system and those lines are going straight into your RV's distribution panel so that it can be, run on both sides. But our Victron that we had, as well as this system, only sees line 1 of the generator, and therefore it can't see any of that power that's available on line 2. And the fix for this is exactly the same like I did in our other generator. Now, the way I fixed this in our old generator, our Onan, as well as this new NPS inverter generator, was I just bridged line 1 and line 2 at its input to the ATS. Now, you might think, oh my God, what are you doing? But these are 2 AC lines that are in phase. They are not out of phase like, coming off of 50 amp power. So therefore, it's just like running lines in parallel in DC. It's just parallel lines coming out of the generator. And what that does is it makes the entire generator visible on line 1, and any loads pulled off of line 1 will be split evenly to those 2 sides of the generator. Now, like I mentioned, I did this exact same thing on our 397, which is a different type of generator, but the end result is the same. What happens behind the scenes is a little bit different. Our original generator was not an inverter generator, so both of those 2 separate lines went to separate windings on the alternator inside that generator, and it just split it evenly. This one's even simpler because it's an inverter generator, and if you look at the wiring diagram for this inverter, you can see there's only 1 line coming off the inverter anyway, and it just gets arbitrarily split to the 2 lines. So basically it's being split and rejoined. It's really no different as far as the inverter where the energy is actually created in that generator is concerned. to create this jumper, this bridge between line 1 and line 2 out of the generator. As I mentioned, I did it at the ATS, the automatic transfer switch, and I just used a 10 gauge wire with 10 gauge ferrules on the end. I use 10 gauge because this thing is only ever going to have a maximum of 3,000 watts or 25 amps going through it. So 10 gauge is fine for that. Coming out of the ATS, of course, that's 6 gauge. So that fixes our issue of generator power accessibility. I think that's how I would say it. But I now have that full power of the generator available on line 1. So now we'll move on to the second phase, the second thing that I found that was limiting my use of power in the system. By default, this RV and the other RVs we had and other ones that I've seen put the main AC on line 1 and then ACs 2 and 3 on line 2 just to keep those heavy loads separated. So what that situation does when I've got a small load on line 1 and a larger load on line 2, let's kind of run through it here with our 3AC example in the default configuration. So let's say I've got 1500 watt AC running. That's just being passed through. Not really a whole lot the inverter is doing to that. And the excess, 1500 watts out of our 6000 available from the generator, the rest of the energy that it can use will go to charging. Now it's 160 amps, so you've only got 1900 watts of power going into charging from that hybrid mode on inverter 1. Sorry, I'm trying to get through this in my brain. So we've got 1500 being passed through, 1900 going into charging, which is a surplus to our DC system. Inverter 2, however, is having to run 2 ACs, maybe about 2500, 2800 watts, but it only is being supplemented by that 1900 watts. So we've got a net negative still on that system. And we're only using 3400 watts of our 6000 watts available from the generator. And the real core of the problem here, or the way to look at this to fix this, is we're underutilizing line 1 where our hybrid inverter is. We could be running a lot more on that line from our 6000 watts from our generator and still passing on that 1900 watts into the DC system to help out inverter 2. So all I did to remedy this was I just moved the bedroom AC, AC2, from line 2 to line 1. Now, if you've ever dealt with your distribution panel in your RV, again, if you haven't or you don't know what a distribution panel is, don't do this. So all I did was I took the AC2 breaker from line 2, moved it up to line 1. Of course, I've got to make room for it. I got to swap something around. And the one that made most sense was a double breaker that was for the microwave and the refrigerator. That's pretty cool. I'll move those down to line 2. So the situation now looks like this. Inverter 1 is now passing through about 2800 watts from our generator to loads on line 1, which is now AC1 and AC2. We still have that excess power because we haven't used all of our 6000 watts to put 1900 watts into the DC system. And now line 2 is only running 1 AC of about 1400 or so watts, usually more like 1200. Those ACs are smaller. So now I've got a net positive. I have extra energy going into inverter 2. I have 1900 watts going into a system that only needs about 1200. So that gives us a net positive of 700 watts going to the battery bank to charge. And this is what we were going for in Key West. I can now run the generator, run all 3 ACs, and end up with a net positive into the batteries to charge during the day, and then go into inverting mode at night. Again, all the numbers I gave you are all just theoretical, just for easy math, but I have tested each of these scenarios with 3 ACs running. I now see a net positive of about 700 watts, which aligns with my theoretical examples. I also have tested running the microwave, running the coffee maker. The system handles those increases. Obviously, it's going to have to pull from the batteries while you're doing that, but as soon as you shut it off, you got a net positive back to your batteries again. But the key is I can be on generator, I can run all 3 ACs, I can run everything in here, and overall, I still get a net positive to the batteries for later on when I want to go into full inverter mode at night. The last thing I want to talk about is that DC to DC charger. As I mentioned, we're not using it, but I wanted to kind of fill you in as to why, because we do get a lot of you emailing us and asking, do you use a DC to DC charger? And the answer is no, simply because you got to think about it this way. First of all, this system does come with it. It's built in. We even have a cable up at our pin box that we could run down to the truck. It will require some wiring in the truck. It does not require a special alternator like the Volta Power System did. But here's the thing, even if I set all that up, the most I'm going to get out of this is 60 amps DC. That's what the charger's rated for. That's about all you're going to get off of a 12 volt line from your truck. That's only 700 watts. I've got 1,300 watts of solar and I got 6,000 watts of generator. 700 watts from the truck is not that important to me, simply because we have those things. Now, if you don't have a generator, maybe you don't have solar, DC to DC charging might be a great option for you to keep your batteries charged. But for us, in this situation, I just don't see a need to modify my truck and put another thing in there and have another cable to hook up. So to summarize, overall, I really like this ELP system. The physical installation is awesome. Having all that stuff out of the way and still getting our front bays, that's amazing. It's got plenty of power. It'll work as is for most people. You know, we're outliers. We had this weird situation where we wanted to camp in the summer and run all 3 ACs, but we found, a fix around that. That now lets us use it fully, even in those extreme situations. Now, the question, you're looking at buying an RV is, should you opt for this system or should you have a system, custom built aftermarket? I mean, because quite honestly, you can have a system built with 2 much bigger inverters running in parallel and much more batteries and a whole roof of solar. You can really max an RV out. I've seen some really cool setups online. But with that, you're going to lose the space advantage of the ELP. So you got to think about that. If you're going to look at an RV with maybe not quite as large a basement, we have a huge basement. We could put more down there. But a lot of these fifth wheels have one pass-through area that's not super big. And do you want to fill that up with inverters and batteries and solar controllers? Maybe, maybe not. Now, again, as I mentioned, as to the price, too many variables involved, particularly in a custom system, but also with buying the system, through the build process. And that could be a factor too, right? I mean, maybe you want to finance all of it into one package. That's going to be more difficult or maybe impossible when you have to build this aftermarket. So there's a lot of variables there, and I can't give you an answer. For us, the system is working really well. It does everything we need. Would it be cool to have like 2 days worth of power and a roof full of solar? Yeah, but we would use it maybe a few days out of the year, if that. This system does everything we need. So I hope you found all this information helpful. I hope I didn't get too confusing with my numbers. If you have any questions, put those down in the comments below. Please subscribe if you haven't already. See you next week.